Um, Welcome, ladies and gentlemen. We're going to start to learn how to solve logarithmic equations and exponential equations. Um, so, the things that you're going to need to know in order to do this, you need to know your rules of logs. So that's the product rule, the quotient rule, and the power rule. Okay? You're going to need to know how to rewrite as an exponential function. And the third thing you're going to need to know exponential form. My spelling is awesome. The third thing you're going to need to know is this whole guy right here. Log base b of x equals log base b of y. This would imply that x equals y. Basically, if you have an equation and a log with the same base on both sides of the equation, then whatever you're taking the log of has to be equal to each other. The only other thing I'm going to warn you about here, the fourth little check here, is to always check for extraneous solutions. You'll see why. Alright, let's look at number one. Number one's the easy guy. We're going to start off nice and easy. I have a common log, base of 10, on both sides. Let's see, they both have a log being taken, so that means that I can use this property right here and just say, well, whatever I'm taking the log of is equal. Same log, same base, so 2x plus 5 is equal to 5x minus 4. Okay, subtract 2x from both sides, add 4 to both sides, and solve. X is equal to 3. Now let's see if this ends up getting me in any trouble. Log base, a common base of, plug the 3 back in. 2 times 3 is 6, 6 plus 5 is 11. Log of 11 is equal to log of, once again, plug the 3 in. 5 times 3 is 15. 15 minus 4 is 11. Hey, I don't see any issues here. We're all good. Our answer is fine. Alright, now let's look at number 2. A little scarier, but not too bad. We have the same base in all three of these things. Base of 6, so that's good. But I can't just drop the logs because these aren't one gigantic log thing. Not yet, at least. We're going to try to put it that way. So first thing we're going to do is we're going to rewrite this by taking these coefficients, these pesky coefficients, and making them the exponents of the inside of our log. Okay, so we have log base 6 of x plus 1 is equal to log base 6 of, remember, this becomes the exponent, so 9 raised to the 1/2. So what is 9 raised to the 1/2? Or what is the square root of 9? That would give me 3. Plus log base 6 of, tricky fingers, tricky fingers. Log base 6 of, I'm going to take this 1/3 and it's going to become the exponent of 27. So what's 27 raised to the 1/3 power? Or what is the cube root of 27? That ends up being 3 as well. Okay, so we got rid of the crazy fractions, which I know you guys love fractions. The second thing is, how do we deal with the fact that there's two logs here? Well, it's an addition problem, so we can actually rewrite this as the log base 6 of these two things multiplied together, because that's the product rule. So log base 6 of x plus 1 is equal to log base 6 of 3 times 3, or 9. Now, this is nice and easy because we have a log base 6 on both sides, only one log base 6 on both sides, and they're equal to each other, so we can drop the logs. X plus 1 is equal to 9, x is equal to 8. So let's see if that ends up working out. We're going to check for extraneous solutions. Log base 6 of 8 plus 1 would be 9 is equal to, now there's no variables over here, so we don't have to plug in any variables over here, and we already simplified this side. So if you look at all the work we've already done without plugging in any variables, it all simplifies to log base 6 of 9 on this side. We found that out right here. So, alrighty, we found our solution. Next, we have natural logs, same base, that's good, but we have an addition problem. Okay, so that means that we're going to have to clean this side up by making this using the product rule. So we have the natural log of x minus 2 times 2x minus 3 equals the natural log of x. Okay, because remember we have to multiply these together. Well, I actually have a natural log on both sides of the equation and nothing but a natural log on both sides of the equation, so I'm going to just drop the natural logs because I can do that. x minus 2 times 2x minus 3 is equal to x. Let's do a little bit of expansion here. X times 2x is 2x squared. This would be negative 3x and negative 4x, which would be negative 7x. And negative 2 times 3 is 6. I'm just expanding this quadratic is equal to x. Okay, we need to solve this by setting it equal to 0. Subtract x from both sides. 2x squared minus 8x plus 6 is equal to 0. And I can divide everything by 2, so I'm going to. It's an equation, so I can actually get rid of the 2. If it wasn't an equation, I wouldn't be able to do so. Plus 3 is equal to 0. I'm going to solve this by factoring. X minus 3, x minus 1 is equal to 0. So x is equal to 1 and 3. Now let's check for extraneous solutions. Okay, so ignore this problem, number 4, for a second. All right, I'm going to take the natural log. I'm going to plug in 1. So natural log of 1 minus 2 is negative 1. Stop. We cannot take a log of a negative number. Doesn't work. If you plug this into your calculator, you're going to end up getting an error message. This right here, we can stop and say, this is going to be an extraneous solution. You cannot have a negative number that you're taking a log of, whether it's natural log, common log, or log base anything. Can't end up with a negative in here. So that's an extraneous solution. Let's try using the 3 now. Natural log of 3 minus 2 would be 1, plus the natural log of 2 times 3 is 6, 6 minus 3 is 3, okay, equals the natural log of just x, which would be 3 in this case, okay? So let's see, I have 2 natural logs on this side. I can use the product rule and say it's the natural log of just the product of 1 and 3, which would be 3. And hooray! So 1 was an extraneous solution, but 3 was not. My answer to this whole thing is x equals 3, my solution. Okay, last but not least, number 4. Looks like I got logs on this side, not a log on this side. Let's first try to combine these logs because they're the same base, so it might be easier to do that. So log base 3 of, this is a subtraction problem, so this is actually going to be using the quotient rule. 4x minus 5 over 3 minus 2x is equal to 2. Now, because I don't have a log on this side, I can't just drop it. But I have a log function set equal to a constant, which means that I know the exponent. 3 raised to the second power is equal to this. Why don't we rewrite it that way? 3 raised to the second power is equal to 4x minus 5 over 3 minus 2x. And 3 squared, hopefully we're all not getting stuck on that step. Alright, 3 minus 2x. How am I going to solve this? I would probably solve this rational function by cross-multiplying. You can think of this as 9 over 1, so I'm going to multiply across diagonally this way. 4x minus 5 is equal to, and across diagonally this way. 9 times 3 is 27, minus 9 times 2 is 18x. Okay, add 18x to both sides, I get 22x. Add 5 to both sides, I get 22. X is equal to 1. Let's plug that in and see if it works. All right. Log base 3 of 4 times 1 is 4, minus 5 is negative 1. Stop. You can't take the log of a negative number. No good. Which means this is an extraneous solution. And that's the only solution we came up with. So, there is no real solution. Woo! Alrighty. So, there you have it. How to solve logarithmic equations using the rules of logs, rewriting logs as exponential form, and using this little nifty guy right here, where if you have logs with the same base on each side of the equation, and nothing but logs with the same base on each side of the equation, you can set whatever you're taking the log of equal to each other. Again, I highly recommend checking for extraneous solutions. Bring in these notes tomorrow, and they will get you through class tomorrow. Alrighty? I see you tomorrow.